Welcome to The Explainer. Today, we're going to talk about something that's at the absolute heart of your network, a device you probably don't think about all that much, but it handles, well, everything, the switch. It's the critical core, and we're going to show you how to lock it down and turn it into a fortress. So let's kick things off with a question. You know, your switch is supposed to be the traffic cop, right? Directing all your data exactly where it needs to go, safely, efficiently. But what if it's just running on its default, fresh-out-of-the-box settings? Well, that's kind of like a traffic cop who's just waving every single car through the intersection, not checking a single ID. And because switches are this central hub for everything, they are an absolute goldmine for an attacker. I mean, why bother trying to hack a dozen different computers when you can just go after the one device that sees all of their traffic? Without the right security, a switch isn't a backbone. It's a giant flashing bullseye, a single point of failure. Okay, so to build a really solid defense, we first have to think like an attacker. So let's open up their playbook and take a look at 3 of the most common and frankly most effective ways they target your network switches. First up, we've got MAC address flooding. So inside every switch, there's this little memory bank called a CAM table. You can think of it as a super fast address book that maps which device lives at which physical port. This attack? It's just pure brute force. It bombards the switch with thousands upon thousands of fake addresses, trying to fill up that address book until it completely overflows. So why would they do this? Well, because once that memory table is full, the switch basically panics. It can't make smart decisions anymore, so it defaults to its dumbest possible setting. It just turns into a simple hub. Instead of sending traffic precisely where it needs to go, it just starts shouting everything out to every single port. And yeah, that means the attacker can now see it all. Next on the list, VLAN hopping. Modern networks use virtual LANs, or VLANs, to build these digital walls between different groups, to keep the sensitive finance department traffic totally separate from the public guest Wi-Fi, for example. Well, this attack is all about finding a sneaky way to jump right over those digital walls. And what this does is just completely tear down one of your most fundamental security layers. By hopping VLANs, an attacker who's supposed to be stuck on the guest network could suddenly find themselves inside a high-security area, listening in on server data, or even getting access to network management controls. Not good. And the last big one we're going to look at is ARP spoofing. See, the ARP protocol is basically the network's honor system. It was designed a long, long time ago and has zero built-in security. This attack exploits that trust completely. It sends out fake messages to trick your devices into thinking the attacker's machine is actually the real network gateway. And this is where things get really, really scary. The goal here is to set up what's called a man-in-the-middle attack. Once your computer is tricked, all of your internet traffic, everything, flows directly through the attacker's machine. They become this invisible spy, able to read, copy, or even change your data before sending it along its way. All right, we've seen the attacker's playbook. It's a little scary, right? So how do we fight back? Well, for every single one of those attacks, there's a powerful defense we can put in place. It's time to build our digital fortress. And here's the good news. For each threat, there's a direct countermeasure. It's almost a one-to-one mapping. We're going to use a feature called port security to stop that MAC flooding. We'll lock down our ports with proper configuration to prevent VLAN hopping, and we'll deploy a really powerful tool called Dynamic ARP Inspection to shut down spoofing for good. Okay, before we get into the nitty-gritty, a quick detour on how switches actually think. They have 2 main modes, a slower, more reliable one that checks all the data for errors, and a much faster one that doesn't. Just about every modern switch uses that faster cut-through mode by default to keep things speedy. Okay, back to our defenses. Now, let's zoom in on our most advanced shield. This is the heavy hitter, Dynamic ARP Inspection, or DAI for short. This is the precision weapon we're going to use to stop those dangerous ARP spoofing attacks dead in their tracks. But here's the thing, DAI can't work alone. It needs a sidekick. First, we have to turn on a feature called DHCP snooping. Think of this as the bouncer at the door of a club. It watches every single device ask for an IP address and creates an official, trusted guest list, the binding database, that says exactly which device belongs to which address. Anything not on that list, it doesn't get in. So then, DAI takes that official guest list from DHCP snooping and uses it as its ultimate source of truth. It's like the head of security now. It checks every single ARP message against that list. If a message comes in trying to claim an IP address that doesn't match the database, DAI knows it's an imposter and blocks it instantly. So the whole process works like a multi-stage security checkpoint. Step 1, DHCP snooping builds that trusted guest list. Step 2, you tell the switch which doors to guard. You mark all your user ports as untrusted. Then, Step 3, you enable DAI. The switch now becomes an inspector at those doors, validating every single ARP packet against the list. Anything fake or spoofed is just dropped. Denied entry. Simple as that.
So, building the fortress is that critical first step. But even the strongest walls need maintenance, right? The job isn't done. So let's finish up with the admin's checklist for keeping that fortress secure, day in and day out.
Now, this isn't just some random to-do list. This is about building a security culture. Simple things like regularly backing up your settings, patching the firmware, and just disabling any ports you're not using. It's all about proactive defense. You're shrinking the surface area an attacker has to work with and making sure you're always prepared. This is what turns security from a one-time project into a continuous, vigilant process. And that really brings us to the most important takeaway of all. Network security isn't some destination you arrive at. It's a process you have to maintain. The threats of tomorrow are being invented as we speak. So the real question isn't just, is my network secure? It's, is my security process ready to adapt? Thanks for joining us on The Explainer.